general solution of the given system. So you are given this system, a system of 3 equations. Okay, first you need to rewrite it in vector x prime, which gives you this one. Basically just take the leading coefficient of x, y, and z, put it down into this matrix, and then multiply by vector x. Okay, so let's call this matrix A. First, phi A minus lambda I, that gives you this one. Then phi its determinant gives you this. Set this equal to 0. Solve for lambda, that gives you 0 in positive and negative I. Okay, so you have distinguished in complex eigenvalues. Now let's do it step by step for each case. Let's take a look at the first case when lambda equals 0. Plug it into this matrix, that gives you this matrix augmented with 0. Okay, so look at the whole matrix. The first equation gives you k3 equals 0. The third equation gives you k2 equals 0. And k1 is everything, so choose k1 1. Then my vector k is 1 0 0. Then my vector x1 is 1 0 0 times e to the 0t, which is 1. Okay, now for lambda, now let's take a look at the case when you have complex value. For lambda equals I, plug it into A minus lambda I, that gives you this matrix augmented with 0. Okay, from the first, now look over this one. For the first equation, that gives me, I have negative I times k1 plus k3 equals 0. Then k3 is I k1. From the third equation, I have k2 equals I k3. Then, okay, if I choose k1 equals 1, then k3 is I. Since k3 is I, then k2 is negative 1. Okay, because I times I, which is I square, and I is square root of negative 1, so that gives you negative 1. Okay, hope that makes sense. If you don't, let me write it down in case you don't know. So I is a square root of negative 1. What is I square? Is negative 1 square root of negative 1 squared. So square root squared, that gives you negative 1. Okay, that's simple. It's just a conceptual knowledge. Alright, then my vector k is 1 negative 1 I. Then my x2 is equal to the real part of vector k, which is 1 negative 1 0 times cosine imaginary part of lambda, which is 1, so cosine t, minus imaginary part of vector k, which is 0 0 1 times sine t. Okay, so for this one, you can combine these two together, which gives you cosine t, negative cosine t, and negative sine t. That's my vector x2. For our vector x3, you just keep this and this the same, change the sign of this one, and switch these two vectors together. Okay, so you bring this up, bring this down, bring this to the left and bring this to the right. Simplify it, that gives you 0 plus sine t, which is sine t, 0 plus negative sine t, which is negative sine t, and then cosine t plus 0, which is cosine t. Right, now your final answer is going to be c1 times x1, which is 1 0 0 from the beginning, plus c2 times x2, vector x2, and vector x2 is this one. Then multiply by e to the alpha t. Alpha is 0 in this case, so alpha is imaginary, is a real part of lambda, so you have e to the 0, which is 1. Okay, plus c3 times vector x3, which is this one, so just bring it down. Okay, so here's your final answer. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.